We stay in the IT, OT discussion area and have a different view, a completing view, how to control the access to the devices from a classical information technology area. This is called privileged identities. Please welcome Yariv Lenchner.
Thank you.
Hello, good morning.
Good morning.
Yariv, you're with CyberArk,
Yes,
right?
I am.
Have you already been involved in critical infrastructure protection?
Yes, a lot.
Projects?
Across the world, it's an emerging market. A lot of people which are dealing with this technology for many years, in the last 2-3 years, started to realize that they have a really big issue with security, and we are there to help them.
Okay, thank you very much. The floor is yours.
Thank you. So good morning, everyone. My name is Yariv Lenchner. I'm with CyberArk, part of their product management team, and I'm focusing on OT and industrial control systems. So I would like to start with answering what is OT. I've been here for the last day and got a lot of questions. So what is OT? So OT stands for operational technology, and it is what drives the world around us. So we can find it basically everywhere. Our power grid is operational technology. The water and sewage that we are using is powered by operational technologies. Oil and gas infrastructure, production lines, traffic lights, transportation system, all of that uses operational technology. Even the building management system in the building that we are sitting in is operational technology. So we understand it's all around us. It is used heavily by humanity. So why do we keep hearing that this technology that is surrounding us is so insecure? There are a couple of reasons. The first is that it is insecure by design, meaning that most of this technology was designed 15, 20 years ago, even 10 years ago, and security wasn't the top priority for the engineers and developers that developed it. This wasn't an issue in this market. Nobody thought about how to hack the power grid, or hack your car, or hack a building management system. There is always, in this area of operational technology, there is a preference for availability over security. A system needs to be up and running, and whether or not somebody is trying to hack into it is not really a consideration. The power grid needs to be on all of the time. This leads to decisions like if you have some kind of an operational system and you need to access it, don't make it a sophisticated and a hard password. Make it a simple password, maybe only 4 digits, and don't use the alphanumeric symbols, just numbers, so people could access it very quickly. That's great, but it's not so secure. Systems like operational technology, especially in the power grid and oil and gas industry and pipeline industry, are up and running 24/7. There is absolutely no downtime, and if there is downtime, it costs a lot of money. So if there is no downtime, there is no really time to do any kind of security patching. So systems are kept on running for many years without critical security patching, leading to more vulnerabilities. And the general concept is that if it ain't broke, don't fix it. Systems are there, systems are running. Don't try and mess with them if it's OK until it's not OK. So if it's so insecure, let's just isolate it from the entire world. We'll have a vulnerable system, but isolated with an air gap and other capabilities from the rest of the world, and then we'll be safe, right? Well, isolation, as I see it, does it really exist? Not so much. We see again and again, for example, we have the issue with removable media. which people are carrying their thumb drives and disk on key, other solutions from one network to another. So even if you do have an isolated network, from time to time, people will bring their own software somehow to it. There are mistakes. If you have some kind of a power plant, which you have one critical network and another more of a corporate type general usage network, people will make mistakes and connect the cable between one to the other. And sometimes people will just put a connection temporarily to do something, for 10 or 15 minutes, and then they'll forget that cable. So nobody knows that cable is there, and there goes our isolation. And of course, probably the biggest issue is that even this so-called isolated network are still connected to the outside world because of third-party vendors that need to support these kind of systems, because of corporate users that need to log on to the operational network. Sometimes we have engineers or technicians that are in a remote location or at home, and they need to access the critical network. Then they will access it remotely. So there is no real isolation. This is something that, in most cases, doesn't really exist, and there are very few networks that are really isolated from the outside world. So we understand there is no real isolation, and we keep hearing that somebody is using that this is not isolated. We see over and over again different attacks against operational technologies. Critical systems are being hacked. Sometimes there is damage. Sometimes only information gets stolen. But we don't know everything. And there are probably even a lot more attacks happening that don't reach the news, because most of these organizations will not go and report to a news reporter about this. So we understand that there is no isolation. We understand that hackers will be able to hack into almost any kind of this network if they spend enough time. Then let's try and understand what a hacker will try and do once he's inside the network. So privilege accounts, this is what hackers are looking for. Most cases, if a hacker is inside the organization, and they will be inside the organization if they spend enough time and money, they won't try and hack or take control of a regular PC of a regular user, because there is a limited amount of information that they can steal or a limited amount of damage that they can inflict. What they will try to do is to take a hold of a privilege account, someone that can really do an account that really allows them to steal a lot of information and do a lot of damage. So this is basically what both malicious insiders and external attackers will try and do. Get the privilege accounts, what we call the keys to the kingdom. And this is a basic flow of an attack. Imagine your organization just above the network perimeter line, where we can see attackers coming from the outside or from the inside. And first thing that they will try to get after they're inside, to get to a privilege account. Once they have a privilege account, they're trying to do some reconnaissance inside our network, our operational and critical network, and do something what we call lateral movement. Move from one server to another, from one application to another, until they reach their target. If they have a specific target, where they will do the stealing of data or the damage that they are planning. So what we at CyberArk are focusing, assuming that an attacker, again, will be able to penetrate the network, and they usually are able to do that, is prevent them from any kind of access to this privilege account. And if they do get access to one privilege account, prevent them from moving to another privilege account by securing this space. So here I'll talk about a specific customer of ours that he had to have his operational network have third-party access because he was very dependent on third-party vendor for support. It's a very large multinational electric utility company, dependent on getting remote access from its vendors, as I said, almost on a day-to-day basis. So it was dependent on a large number of vendors. Vendors keep calling the control room asking for remote access. So it was very hard to keep track on what vendor got access to what system and when and why, what is he planning to do, who authorized this access. So all of this information and approval process, once you're talking about a big multinational utility, that's a problem. You have too many people accessing your most secured users, your privileged users from remote, and you don't really know what they're doing. And if something breaks, who's going to take the fall for it? So what we've done is implement our solution, the privileged session management, taking control of all of the process of getting approval from remote third-party vendors, providing them access to our privileged accounts remotely. We know exactly who's the person accessing this privileged account. We know why, we know when, and we control whatever he's actually doing, and we can even record it. Now, I won't get into the technical bits of it, but we can see on the top a general view of what an OT network will look like. We see the OT network at the bottom. We see the corporate network at the top. We see some kind of a DMZ between those networks. And a remote third-party vendor, after he will get the usual VPN access to our DMZ, then he will need to go into a session approval process where the solution will authenticate the specific user. We don't just rely that this is an employee of some vendor. We know exactly who this person is. We give him only we authorize him to access only the specific the systems that he actually needs. We can even make him ask for permission. So he will say, I need access to system A from 9 to 8 or from 9 to 10. I'm doing this kind of work. I need to patch something. I need to upgrade something. I need to change the configuration. So all of this information is logged. We have someone on our internal network that we trust that will approve this. So taking control of this process and allowing that third-party vendor have access to whatever system he needs. All of this, even if that remote user we allow him to access some privileged account, he is not aware of that privileged account password. In our process of letting him into the network, we do the logging of the session, and we just provide him with the access. So we can create this kind of isolation between the remote third-party vendor and the target system, making it isolated from attacks. One more thing is that in this world, it's different from the IT world, of course. You have different devices, different protocols, different technologies. One of the technologies that we've been working on is an integration with the GE Energy, for example. One of their very well-known device, the D20. We've worked with GE Energy on this, making sure that our system can manage privileged accounts on top of this device. This is an IED, an intelligent electronic device. Usually you will find it in electric substations. You can, an electric utility could have hundreds, maybe thousands of those devices. So it's very required. It's very important to manage this kind of accounts. In specific, there are specific regulations for this. In North America, there is a specific regulation that requires energy utilities to manage these privileged accounts. And the regulation is called Newark Zip. And this is something that we've done with GE Energy. So this is a very good example of how we take technology that was born and built for the general IT security, and you can use it for the OT world as well. So to summarize, as I said, with enough effort, hackers will get into any OT network. It's just a matter of time and energy and money. Once inside, these hackers will try to get a hold of a privileged account. And so this is the focus, preventing remote hackers or users from accessing your privileged accounts without the control of your supervisors and your IT security team. That's it. Thank you very much. If you have questions, I'm at the CyberArk booth. Thank you.
Thank you very much, Taif.
Thank you.
I assume you made one basic assumption, namely that the protocols are secure, right? I mean, the privileged identity is of primary importance if I have no chance or I need a high effort for actually getting past the authentication, right? So, so this is an excellent solution, but what do you recommend for addressing this this vulnerability at the protocol level?
Mm-hmm. Well, there are issues with the protocol level, of course, and this is why a lot of utilities try to isolate. You have vulnerabilities, then you try to isolate. And this is another good example why, if you can't trust the protocol, then you really need to check whoever has access to this network. And this is, again, another reason why you need to have something or some solution that will control any access, privileged or non-privileged, to your very sensitive network. Because if there's a problem at the protocol level, it's very big. It's not something that a single vendor or a single solution can solve. You have to really isolate it and use something like what I've described to control whoever have access to that network.
Okay. So it basically means that the protocol level is an additional topic to address besides the identity management.
Yes,
piece.
It's another vulnerability, and just making the isolation even a bigger problem.
Okay. Thank you very much again.
Thank you. Thank you.